Hey everyone, welcome back. In the last video, we have solved a problem on math and stack. In that problem, we had an array of elements in which there was a numbers as well as the operator. So we used math as well as stack to solve our problem. So today we are going to solve one more medium problem from Leetcode, which is factorial trailing zeros. Okay, so I hope you know what is factorial because it is from the math itself. Okay, so let me explain what is factorial. So let's say if you have a number 3, so what will be the factorial of that number? So factorial is basically the multiply all the numbers from 1 to n itself, right? So the factorial of n equals to 3 will be 6. Similarly, if you take n equals to 5, the factorial will be 1 into 2 into 3 into 4 into 5. So whatever you will get here, it will be the factorial of n equals to 5. Okay, now let's say we have a factorial here 6 into 20 and it is 120 for n equals to 5. Okay, so for n equals to 5 we have factorial 120. Now what is trailing zeros? Trailing zeros means if you have number like this and after number we have zeros, these zeros are called trailing zeros. If you have number like this, these are leading zeros, okay, because they are in front of the number, and if zeros are after the number then it is trailing zeros. So basically our question is, you have given any number, let's take 4, you have to find the factorial of that number, okay, and you have to print number of trailing zeros. So after finding the factorial, how many trailing zeros are present in that number? For n equals to 5 we have 120, so it have only one trailing zero. For n equals to 10 there may be some of the trailing zeros. So basically we have to find the factorial, then count the trailing zeros. So let's look at the problem. So we have n equals to 3, the factorial of this will be 6 and there is no trailing zero, so our answer will be here 0. If you have n equals to 5 and factorial will be 120 and the trailing zero will be 1, okay, and if you have n equals to 0 and factorial it will be 0. So the definition of trailing zero is you should have number before the 0. Here you don't have any number before the 0, so it is not a trailing zero. So how we can solve this problem? So in this problem we have two steps. First is factorial, right? Second is counting trailing zeros, right? So first we will find our factorial. So what's happening, if we have n equals to 5, to find the factorial we just have to multiply from 1 to 5. So for multiplying we can run our loop till the n, and we will take one variable which is fact into equals to I. So here we will declare fact equals to 1. So initially we have I and the fact, if I is 1 then factorial is 1, then I is 2, factorial will be 1 into 2, I 3, factorial 1 into 2 into 3, then I equals to 4, factorial will be 1 into 2 into 3 into 4, then 5, 1 into 2 into 3 into 4 into 5. So we will be able to get your factorial like this. Here we are doing a multiplication in every iteration, so you will be able to find your factorial. One more thing, in one of the videos I have told you, whenever you are doing a multiplication here, this variable will overflow. To avoid overflow, take this factorial as a long, okay. If you try to take int will only store up to 10 to the power 9, but long can store up to 10 to the power 18. If you are multiplying, in that case take long instead of integer. Okay, now we were able to find our factorial. So let's say we got our factorial something like 120. Now we have to count the zeros, or we can say we have to count the trailing zeros. Trailing zeros means we have to count zeros from the back, and this is our number, right? So can we do a extraction? If we do 120 modulo 10, it will be 0, right? If I do 120 divided by 10, it will be 12. 12 into modulo 10 will be 2. 12 divided by 10 will be 1. Then 1 modulo 10 will be 1. 1 divided by 10 will be 0. Right? Here we are getting our reminders in these steps. So if you are getting zeros in the reminders before any number, we can say it is a trailing zero, right? So if we are getting a reminder equals to 0, can we do a count plus plus for the trailing zero, right? Now why I said before any number, right? Let's take another example. Let's say if you have a number factorial equals to 1050, something like this, you will get here 0. So here you able to get count equals to 1, right? Then divide, it will be 105, 10 modulo 10 will be 5, then 105 divided by 10, it will be 10, then 10 modulo 10 will be 0. Here you can see in this case also we are getting zeros, but this 0 is coming after some numbers, right? But we have to only count the zeros before any number, so our count should be 1 only, not 2, right? Because we are getting 0 here as well as here as a reminder, but we want only this 0 because this is the trailing 0, not this one. So that's why we have to count only trailing 0 before any number. Okay, now how we can do it? So basically it is extraction of the digits. So if we are doing extraction and if we are getting 0 as a reminder, we can say it is a trailing 0, right? So let's write our complete code here, then we will write on the console. So let's first declare our factorial 1, then we will run our loop I equals to 1, I less than equals to n, I plus plus, then factorial multiply equals to I. Then let's declare one more variable count, which will be storing our count of trailing zeros. After that we will do a extraction of zeros, right? Then we will find remainder factorial modulo 10. If our remainder is equals to 0, then we can do a count plus plus, else we will break, right? Because if you are getting 0, then you will count and continue. If you are getting a number, you don't have to continue, right? Because even if you get a single number, then after this number any amount of 0 is not a trailing 0. So if even you get a single number, you should break from here, then factorial divided by 10. So this is our whole code. Okay, first here factorial, then here we do a extraction and count trailing zeros. Now let's analyze the time complexity. It is running for 1 to n times, so it will be big of n. For this you already know it will be log of factorial, right? Because factorial is our new number, so it will be log of factorial. So overall time complexity will become n log of factorial. Okay, and space complexity will be big of 1 because we are not using any extra space. So now let's run this program and see it is working or not. So this is our problem, and you have given integer and you have to return the number of trailing zeros. So for the 3 you have 0, and for n equals to 5 you have 1 0, right? For 0 you have 0. So let's handle our 0 case here itself. Okay, because if you try to extract or find a factorial, you won't get anything. So why do we need to solve for n equals to 0 also? Now let's declare our long fact equals to 1, then we will run our loop and factorial multiply equals to I. After getting factorial, we will declare count variable which will be storing our count of trailing zeros. We will run while loop to extract our digits. Then here we find remainder, it will be fact modulo 10. If remainder is equals to 0, then we can say it is a trailing 0. Else if you get a number, you will break from there, and here you will update your factorial number. After that let's return our count. So now let's run it. Here you can see for the initial test cases it is working. Now let's submit it. Here you can see we got a integer overflow. Let's make some changes here. Let's do a 1 ll into fact. Okay, here 1 ll means it is long. Okay, it is one way to convert it to the long itself. Okay, now let's try it. So it is still not working. So basically this number is really very big number which is exceeding 10 to the power 18. So that means this program is working fine for smaller numbers, but for the bigger numbers this program is not efficient, right? So if you try to write this code for a smaller number of factorials, it will work without any problem, but for larger number it will not work. So here they have given one more line at the end. could you write a solution that works in a logarithmic time complexity? So let's come to the tab. So here our time complexity is n log factorial, right? So here we have n as well as log. So they are asking only in the term of log, because n into log will be really big time complexity. So now we have to write a code in only log factorial. That means we have to eliminate this for loop, because this for loop is taking wig of n. So how we can eliminate? Now for this you have to understand one concept. So let's take n equals to 3. Okay, now the question is, when the trailing zero comes, means trailing zeros basically are in the number of 10, 20, 30, 40, 50 and so on. These are our trailing zeros, right? Any other number than this, they don't have trailing zeros. So it can be write like this: 2 into 5 equals to 10. For this can we write like this: for this 3 into 5 into 2, for this 2 into 2 into like this and so on, right? So what is the common in all of the numbers which making them trailing zeros? It is 5. So basically the 5 is the only number whose multiples are having 0 as a trailing zeros. So instead of finding the factorial, we just have to find the trailing zeros, right? So if you have number 3 and if you do a divide by 5, it will be a 0, and if you have number 5 and do a divided 5, it will be a 1. N equals to 10 divided 5, it will be a 2. N equals to 13 divided by 5, it will also be a 2. We have factorial of 3 is 6, and 6 does not have any leading zeros. Factorial of 5 is 120, which have 1 0. Now let's see what is the factorial of 10. So for factorial of 10, we have 3, 6, 2, 8, 8, 0, 0, which is having 2 leading zeros, right? Let's see what is the factorial of 13. It is 6, 2, 2, 7, 0, 2, 0, 8, 0, 0, 2 factorial, right? So we just have to do a divided by 5. It will give you a count of leading zeros, because 5 is the one who is making your numbers to have leading zeros. Here you can see 5 into 2 10, then 2 into 5 into 20. So let's write the code for this. We will declare one variable count equals to 0. We will run our loop in which we are dividing our number n by 5 and doing a count of n by 5 and updating our n. This is the code for this logic. So what we were doing, we are directly dividing our n with the 5, and what is the value is remaining is giving me the number of trailing zeros. Okay, and also we are doing here floor, which is basically round off your value after dividing it, and here we are doing a plus equals to. Okay, so it will add all of your trailing zeros. 13 divided by 5, in one iteration it will only divide one times, right? So it will give you a 2.2, and doing a floor will round it up and it will become 2, then 2 divided by 5, then it will become 0, right? So this number of iterations is giving me the number of trailing zeros. Okay, and after that here we are updating our number. So what will be the time complexity? So here you can see we are dividing our number. If we are dividing, then it will be in the log of n terms. So this is our time complexity for this code. Try to dry run it yourself on different examples, so you will be able to understand it what is happening. But remember one concept, that whatever number we have which is having 0 at the end, it is due to 5. Okay, so all these are zeros are due to these 5. Okay, 5 is the one who is making zeros at the end of the number. So we are using that concept and dividing our number 5 itself and counting the number of trailing zeros. Now let's write our code. So this time we don't need this. Let's handle the 0 case, then let's remove this also. Here this time we will directly write our n, then we will do a count plus equals to floor and n divided by 5. Then here we will return our count. So let's run it. Here you can see it got accepted, right? This time we don't have to take long, because this time we are not doing a multiply, instead we are doing a dividing. So at every iteration we are making our number smaller, so we don't have to take care of anything. Also we are not trying to find the factorial also, because here we have 10 to the power 4, so we don't have to go beyond 10 to the power 4. So this code will run and our time complexity is big of log n. Okay, so that's it for today. In the next video we will solve more problems. Until then, thank you everyone. Have a nice day.